Welcome to Retina South Africa, bringing you Chapter 6 in the Back to Basics series. We would like to acknowledge that our education activities are supported by unconditional grants from both Bayer South Africa and Roche Products. In our previous webinar, we spoke about the chambers and the fluids in the eye. And we noted that none of the chambers in the eye is empty. They are all filled with different types of fluid. In today's lesson, we are going to look at light, and more specifically, how light interacts with the eye. The eye, as we know, is the sense organ that allows us to see the wonderful, colorful world around us. And we are able to see basically because of many properties of light. The first thing is that light consists of little packets of photons, and these travel through the air or travel through different media in waves. Now, the waves differ completely in size. There are tiny little ripples and there are giant waves. The entire electromagnetic spectrum of energy that we find everywhere consists of these waves of energy, but very, very little of it can in fact be seen by the human eye. If we look at the different wavelengths, for example, radio wavelengths are enormous. Then we have microwaves, infrared rays, and the visible spectrum is very, very narrow when we look at all the different wavelengths, in other words, the entire spectrum of different wavelengths. Then we get ultraviolet, X-ray, and gamma rays. And once again, to stress that the only wavelengths that we can see and interpret as light encompasses a very narrow proportion of this entire spectrum. The sun provides our visible light, and it provides us in the form of white light. And the light waves always travel in a very straight line out from the source. So if you look at light shining through clouds or through trees or anything like that, you'll always notice that there is a very straight line. And even if you look at a torch or a candle or anything, the little rays coming from any of these devices or from the sun or from any light source whatsoever, they travel in direct straight lines. Light rays travel at an astonishing 300,000 meters every second. And this is why it takes only 8 minutes for the light from the sun to reach our planet, bringing that white light that we so need for sight, even though that is approximately 150,000 kilometers to travel. Now, white light actually consists of a blend of different colors that we divide into 7 different wavelengths. Each of the 7 colors has a very specific wavelength. If you look at a rainbow, at any time, you will notice that there is red, orange, yellow, green, blue, indigo, and violet. And interesting, the red is always on the top. And as light travels through a prism, exactly the same happens. The white light splits into those 7 colors. Once again, red always appears on the top. Interesting, if there's a double rainbow, in the second rainbow, the color is inverted. So anytime that you see a rainbow, you can now look out for this phenomenon. As we said, white light actually consists of red, orange, yellow, green, blue, indigo, and violet. And the most important of these from a visual point of view, from our eyes' point of view, is the red, green, and blue. And we're going to look in a moment at why this is. The reason is because the light receptors in our eyes, known as the little photoreceptors, can receive blue light, green light, red light. So red, green, blue. And those 3 receptors receive those 3 colors, but manage to send a mixture, almost like when you blend paint together to get different colors and hues and shades. Exactly the same happens. This mixture goes to the brain, and we see that blend of light as hundreds of thousands of different colors. So taking only red, green, and blue through the different receptors, one for red, one for green, one for blue, collect those, as we said, almost like blending paint, send that mixture to the brain, and we can then interpret that entire rainbow of light and the different colors contained therein. Now, there are a couple of terms that we need to understand and that relate to light. The one is reflection and the other is refraction. So let's look at these in turn and see what the difference is, especially when we go to visit an optometrist or an ophthalmologist. First of all, reflection is the change in direction of light when it hits an object and then bounces back. For example, if the light from the sun hits a tree, as you see in this picture, and that light then reflects back to us, that is reflected light. And very commonly we know that if you look at something in a mirror, those rays of light are being reflected directly back to us from the mirror. So reflection just means the bouncing back of light to our eyes that is not coming directly from the original light source. And when you look in a mirror yourself, you see a reflection of yourself. Refraction, on the other hand, is the bending of light when it travels through virtually any medium, whether this is glass, water, gel, plastic, anything that is transparent. And as it travels through that medium, you'll notice that if you put a straw into water, or in this case a pencil into water, the straw or the pencil or whatever seems to bend, and that is refraction. It is the bending of light. And also note that light bends every single time it passes from one medium to another. So in this case, as it goes into a plastic or a piece of glass, it bends and then it bends again when it exits. And this is the same as happens in the eye, in the cornea and the lens. The light bends as it travels through these. Any medium that light travels through will cause a bending of that light. So then, what is sight? We now know that the eye receives light rays in the form of photons, the little packets of light. These travel through the cornea. The photons pass through the pupil, and the pupil, as we know, is controlled by the iris. And the lens then bends, or we now know the correct term is refracts, the light so that it can focus directly on the retina. And then, just to recap again, in the retina we have these specialized cells called photoreceptors, and as the name implies, these cells receive light. They're light receptors or photoreceptors. There are 2 types of photoreceptors. They're rods and cones. We've already discussed cones, which are the red, green, and blue that receive the different colors. And the rods do not perceive color, but they are very sensitive to the presence of light. And then, as we end, just for a bit of breaking news regarding light, research is showing that light during the night not only interferes with sleep, it also predisposes people to diabetes. And you can read about this article in the link given to you there. It was published in July 2024. In our next episode, we're going to start looking into the retina in a lot more detail. And if you have any questions, as always, please send an email through to headoffice@retinasa.org.za or call us on our share call line 0860 59 5959. Thank you.